Okay, this lesson is on Cartesian and polar coordinates, written and presented by me, Sean LeGuay. This is all the legal stuff. Right, firstly Cartesian coordinates. They're the ones that we're actually used to. They're named after Descartes, the mathematician and philosopher. If you have a point, you can describe where that point is using its x and y coordinates, where the x is how far across and the y is how far up. So in our case this is 4 across and 3 up. So its xy coordinates are 4, 3. Polar coordinates are named after the fact that there's a pole involved. A pole is a central place. We describe a point by how far away it is and at what angle it is from the pole. In this case, it's 5 away from the pole, and the angle is 36.9 degrees. So its polar coordinates are 5, 36.9. To convert from one coordinate system to the other coordinate system, we can use a little trick discovered by Pythagoras. Let's tidy this up. Get rid of the point and get rid of the graph. And you can see that what we have left is a right-angled triangle. Pythagoras discovered that the area of the square on the big side is the same as the area of the other two sides put together, the squares on the other two sides. I'll just show you that. If I put the little blue square inside the big green square, and then I divide up the rest of the green square like that, you can actually see that the red square fits exactly into that. So the red square and the blue square fit exactly into the big square. Put back all the coordinates. Now we can see that the equation is that the big side, which is r squared equals x squared, which is the red square, plus y squared, which is the blue square. In our case, r is 5, so we've got 5 squared equals 4 squared plus 3 squared. And if you do the sums, you'll see that that is correct. I can get rid of the square bit by square rooting both sides. When I square root the r squared sides, I end up with just r. And then I square root the other side, and I end up with the x squared plus y squared underneath a square root sign. So, in conclusion, what we have is we have Cartesian coordinates, x and y, which is how far across and how far up. Polar coordinates, r and theta, which is how far away and at what angle. To go from Cartesian to polar, the r we can get from Pythagoras. The theta we need to use an inverse tangent function, which we're going to learn about in a future lesson. To go from polar to Cartesian, we use sine function and cosine function, which once again we're going to learn about in future lessons. So all you need to know about polar and Cartesian is that Cartesian is how far across and how far up, and polar is how far away and at what angle. That's it.